Today we will discuss about subprograms and blocks. This is the third unit of principles of programming language. Subprograms and blocks. First, introduction to subprograms. The first programmable computer, Babbage analytical engine, built in the 1840s, had the capability of reusing collection of instruction cards at several different places in a program. This is the definition of subprogram. Collection of instruction cards at several different places in a program. In a modern programming language, such a collection of statements is written as a subprogram. This reuse results in savings in memory space and coding time. Such reuse is also an abstraction, for the details of the subprogram's computation are replaced in a program by a statement that calls the subprogram. This increases the readability of a program by emphasizing its logical structure while hiding its low-level details. Next, basic definitions of subprograms and subprograms. Basic definitions. A subprogram definition describes the interfaces to and the actions of the subprogram. Abstraction. A subprogram call is an explicit request that a specific subprogram be executed. A subprogram is said to be active if, after having been called, it has begun execution but has not yet completed that execution. A subprogram header, which is the first part of the definition. Consider the following header examples. Define adder parameters using def keyword. This is the header of Python subprogram named adder. Ruby subprogram headers also begin with def. The header of a JavaScript subprogram begins with function. This is a Python program. In Python programming. In C, the header of a function named adder might be as follows: void adder parameters. In Python programming languages, define adder parameters, and in C language, void adder parameters. The reserved word void in this header indicates that the subprogram does not return a value. In the C-based languages and some others, for example JavaScripts, the body of subprogram is DELM. Subprogram is be limited by braces. In Ruby, at end statements terminates the body of a subprogram. When a define statement is executed, it assigns the given name to the given function body until the function's define has been executed. The function cannot be called. Consider the following skeletal example. If define function, else define function. All functions are anonymous, although they can be defined using syntax that makes it appears as though they have names. For example, consider the following identical definitions of the function cube. Function cube of x, return x end. Cube equal to function of x, return x into x end. Parameter subprogram. In function parameter, how parameters passing in subprograms. The parameter profit of a subprogram contains the number, order and type of its formal parameters. There are two ways that a non-method subprogram can gain access to the data that it is to process through direct access to non-local variables, means declared elsewhere but visible in the subprogram, or through parameter passing. Data passed through parameters are accessed using names that are local to the subprogrammer. The parameters in subprogrammer header are called formal parameters. For example, we can pass parameters in subprogrammer header. The parameters are called formal parameters. They are sometimes thought of as dummy variables because they are not variables in the usual sense. In most cases, they are bound to storage only when the subprogram is called, and that binding is often through some other program variables. Subprogram call statements must include the name of the subprogram and a list of parameters to be bound to the formal parameters of subprogram. These parameters are called actual parameters. The bound of the parameters means formal parameters of subprogram is nothing but actual parameters. In Python, Ruby, C++ and PHP, formal parameters can have default values. A default value is used if no actual parameter is passed to the formal parameters in the subprogram header. Consider the following Python function header. Define compute pay income exemptions equal to 1 tax rate. The exemptions formal parameter can be absent in a call to compute pay when it is the value 1 is used. For example, consider the following call. Pay equal to compute pay 20,000, tax rate equal to 0.15. In this example, we can miss the exemptions. In C++, which does not support keyword parameters, the rules for default parameters are necessarily different. The default parameters must appear last because parameters are positionally associated. Float compute pay, float income, float tax rate, int exemptions equal to 1. If display list is defined for the class my class and we have the following declarations. My class my object equal to new my class. Into my list equal to new list of values. New int of 6. Display list could be called with either of the following. My object dot display list of my list. My object dot display list of 2, 4, 3 into x minus 1, 17. Parameter structure of Ruby subprogrammers support variable number of parameters. This parameter is called the array formal parameter. The following example skeletal function definition and call illustrate the formal structure of Ruby. List equal to 2, 4, 6, 8. Define tester of P1, P2, P3 star P4 and tester of first comma, Monday greater than or equal to 72, Tuesday greater than or equal to 68, Wednesday greater than or equal to 59. Into list. Inside tester, the value of its formal parameters are as follows. P1 is first, P2 is Monday greater than or equal to 72, Tuesday greater than or equal to 68, Wednesday greater than or equal to 15. P3 is 2, P4 is 4, 6, 8.